Welcome. So, first of all, mention in the comments how did you find that animation? Today, we are going to introduce the topic of integration. So, this is like a long coming video, which is basically helping us in studying kinematics. So, let us begin. So, first of all, we want to define what is indefinite integration, right? So by indefinite integration, we mean that we are basically trying to get a function. So in some way, it's something like differentiation. In differentiation, we have some function, we do some operation on it, and we get some output function. For example, let's say I'm differentiating x. If I differentiate x, I'll get 1 because that is the slope of its curve. In the same way, integration is the inverse process of differentiation. So this means that if I have already have a function, so I want to find that function whose slope is the function which I have. So this uh, is like a pretty straightforward process at first. For example, the thing which I mentioned, let's say if I have x, I differentiate x, so I got 1. That means if I integrate 1 with respect to x, so I should get x. In the same way, let's say if I'm differentiating 2x, so I'll get 2. So if I integrate 2, I'll get 2x. So things like that. So at the surface, it is pretty simple process, but it's like a big branch of mathematics. So it's pretty exciting. We are going to do a lot of that in today's video. And let's begin with the definition. So integration is the inverse process of differentiation. So we are going to take help of lots of animations in this um, particular video, so as to make it uh, clear to the viewer that what is the integration which you want to do, right? So basically, the first integration which we want to do is that of x. So if I'm integrating x with respect to dx, I desire to find a function whose differentiation is going to be x. So you would be knowing that if I have x square, differentiation of x square is x, 2x, sorry. Differentiation of x square is 2x. So if I divide x square by 2, then the differentiation of x square will give me 2x, and that 2 will get cancelled out with this 2. So after cancellation, I'll get x only. So that means integration of x dx is x square by 2. Proceed in uh, differentiation or integration. So differentiation is the process in which we get from this point to this point, and integration is this forward process in which we get from x dx to x square by 2. So graphically as well, I want to express what is integration. Algebraically, we have taken an example, but what does it mean actually? So let's say I have a function um, like this, drawn like this. Now this function which I have, let's say this function is capital F, okay, and it is varying with x, and it looks like something like this. Okay, so we know that the differentiation of this function gives me the slope of this tangent at different points. So if I were to draw the graph of its uh, differentiated value, let's say it looks something like this. Let's say it's looking like a straight line. I hope it is visible. So there's a straight line, right? Um, so now let's say this new function which I have got is small f. Okay, so if I know what is the slope of the function capital F at every point, I am able to plot all those points on this new curve to get this slope, right? Uh, but what if I already know the slope, then I want to get this original function? That is what integration is. So if I integrate the smaller function, I should this get this capital F, right? Um, Take for a moment, what if I take a graph like this? Now, if I take a slope at the same point, wouldn't the slope of this new curve be same as that of the curve beneath it? So if I were to draw a new function whose slope at all points is same as that of the curve below it, let's say this function is x square and the above function is x square plus 1, then although both the curves are uh, distinct, but the slopes of the both the curves at all the points are exactly equal to this graph. That means that even if we differentiate these two curves, we'll get this curve. Upon integration of this curve, we'll get this curve and a lot of other curves. One more curve is this one, x square minus 1. So this is what integration is. Basically, we already have this curve, which is small f. Now, from the small f, we want to get to the equation whose differentiation gives me back this small f value. But the point is that we are getting a lot of functions whose slope at all the points matches that of small f. So that means that when we differentiate, we are getting a single function. But when we integrate, we are getting a family of functions. So this is called a family of curves. Family of curves. So though when we write our integration expression, you would have seen that I wrote something called plus c. So that plus c is because of this. We write that if differentiation of this small f curve gives me capital F, then the integration of this capital F curve, or what I want to say, the integration of this small f curve with respect to dx will give me this function capital F along with a lot of whole lot of curves which are called a family of curves. So because their slope is unaffected by this constant c, we can take any value of this c. Okay, so this is like a number, just like some constant, arbitrary constant we say. So its number can be, value can be anything. So we name it as C only. So this C is called constant of integration or some arbitrary constant. But the key point is that what is integration? Integration is basically getting to that original function whose slope is contained by the function which we have. So we know the slopes of all the tangents. When we want to get back to that original function, that is what integration is. And differentiation is definitely getting the slopes of the function. So if you guys just give me a moment, I want to check. Yes. So let's see which are the functions which we want to integrate today. So the next function which we want to integrate is sin x. Integration of sin x is all about imagination. What is integration? So integration means that ki whatever value which we are getting, its differentiation will be sin x. So we know that cos x differentiation is sin x. C you already know. C is constant of integration. So the value of C we'll have to just put as C only. Differentiation of cos x is minus sin x. So we'll have to anticipate that and put a negative sign here. So that means integration of sin x is minus cos x. Next, next function which we have is x dx. This its value is x to the power n plus 1 upon n plus 1 plus c. So this is rather easy to remember. Your power gets added up and that added value comes in denominator. So it's pretty straightforward. Integration of cos dx. So integration of cos x dx, we know sin x, differentiation of sin x is cos x, so integration of cos x is simply sin x. Then the last function which we have is ax dx. Differentiation, the value of a comes outside. Here also, a will come outside and will integrate x as is. So you already know integration of x is x square by x square upon 2. So this will become a into x square by 2 plus c. Then we move on to definite integration. Definite integration means putting some limits to our value of integration. That means that okay, now we want to find some definite value and rather than putting some value of c and things like that. So what is definite integration? Definite integration is basically saying that okay, I have got some function, let's say f, I integrated that function to get capital F, and now I want to integrate them between these two values a and b. So the lower limit is some value a while the upper limit is some value b. What do they mean? So let me explain. We say that okay, we have some curve, the function f. If I want to find what is the area between x equal to a, right? The value which we are varying is x, and from a we are starting the variation to b. So from a to some b value, if I want to find the area, this area is equal to f of b minus f of a. So this indefinite integration is basically finding area beneath the fx curve and x-axis between x equal to a and x equal to b. So let me explain what I said, what I meant by saying that. Okay, you can put the value x equal to a here and x equal to b here. So we are basically saying we'll put the value x equal to a here, okay, in the function which we have integrated. Okay, so whatever function which we'll get in that value, in that function we'll put the value small a, and the other limit, the value b. So we'll put the value b first and then put the value a and put a minus sign in between them. This gives us the definite integration. So let me demonstrate by example. So, okay. Um, mainly the first function which we integrated, if you remember, was integration x dx, right? So similar to that, we have other functions ready for that. One of the first functions which we have is this dx to the power n plus ex to the power m plus c. Okay, we want to integrate this. So I want it to be clear what we are integrating first, right? Because that is our focus. What we are integrating, that is important. So we have this dx to the power n plus ex to the power n plus c. So we integrate this. We integrate this value dx from some value. We can take the function to be varying from some value, let's say a to b. So it is going from a to b. Okay. So we have already recognized that k, d, e, and c, these are some constants. Okay. So because they are some constants, we know that k, um, they are not to be trifled with. We can straight go to x. So while integrating this, basically take a breath and divide your integration among these positive signs. By which I mean is that can integrate this dx to the power n like this. Okay. Then distribute the terms along the positive sign. Then the other thing ex to the power m. Then the positive sign. Then integration c dx, and your that's it. So along the positive signs, we have distributed our integral, just like we do in differentiation, and also with the limits as well. This b, a, b, a, b. Here I would like to mention that this value b This is called upper limit, and this value a, this is called lower limit. This value dx is called the element. Okay, these are simple names. Okay, so but they are relevant to physics. From that point of view, I am saying. Okay, function, you would the word you would be knowing what a function is. Okay, it's not like a marriage function. Okay, but still it's something like a it's some kind of operator in which you put some value, it operates on it, and you'll get some outcome or output value. So that is what integration is. Integration is basically saying that okay, you have a function. Now get to that function, uh, which will get whose differentiation is what we already have, right? So let us integrate all of them. So we know d will take outside integration of x to the power n. So we say x to the power n plus 1 upon n plus 1. It goes from a to b plus again mentioning the d value of d, not forgetting it. Value of e also written to the side. X to the power m integration is x to the power m plus 1 upon m plus 1 plus c. Integration of dx is simply x. Value goes from a to b. So it's simply putting the value b and a. So just like I told in the example that we'll be first putting the value b, upper limit first we'll put. The value of b will put first, and I hope it is visible. So the value b, if I put here, so we have to put in the value of x, not in n. So it will become b to the power n plus 1 minus sign, because there was a negative sign between my f of b and minus f of a. Then put the value of a. A again will put in x. So this will become a to the power n plus 1 upon n plus 1. Now you would have got, right? Same thing we are going to do here. We are going to put the values a and b and the value x to the power n plus 1. So denominator is constant only, it will remain as is m plus 1, and the numerator would be b to the power m plus 1 minus the value a will put, that is m plus 1, plus c, the value b will put here, this will become b minus a. So it's pretty simple. Whatever function you have got, you put the value upper limit first, negative sign, lower limit next. So in the animation which you have put, the animation does not isn't able to put the value b and a in the function. It has just put that in the limits. But it's still pretty good, right? Okay. Next, we want to integrate sin x from 0 to pi. Okay. So, first of all, what is integration of sin x? So that we already know. Integration of sin x, it is minus cos x, right? So that we have already done. So that is the advantage of doing indefinite integration. Okay, that's why we have done it. Okay, because while doing indefinite integration, we want to be pretty uh, smooth with finding what expression of integration we are going to get. limits 0 to pi. So one question can be coming in your mind, ki, okay, what is this application in physics as such uh, that I am talking about upper limit, lower limit, and elements and so on. But from the physical point of view, how is it relevant? So I'll tell. Basically, I have, let's say, some particle whose position is sine x or sine t. Okay, x can be replaced by time. And I want to find the displacement of the particle. So if I integrate velocity of the particle with time, I'll get its displacement. So this is the velocity. I'm saying, okay, I earlier said this is the velocity of the particle, sin x. This is the time. Okay. The velocity is varying with time only. Okay. Although it is x, imagine that okay, this is t only. So this is sin t and dt. So corresponding to that, when time goes from 0 to pi second, what is the displacement of the particle? Okay. So once more, I'll repeat what I have said. I have some particle whose velocity is sin t. I want to find the displacement of the particle from its velocity. Now, as such, this is like a question which should be pretty simple for us to understand from physical point of view. Because we know that if I know velocity of particle, multiplying it with time gives me the displacement, right? So integration is helping us in that way only. Integration is saying that the velocity is not constant, so you cannot directly multiply it. What you can do is that you can take a velocity v, you can multiply it with small time, and you can add up all the small displacements from 0 to pi. Okay, so it gives you the complete displacement. Okay, so this value will get minus cos pi minus minus cos 0. Minus cos pi is 1 plus 1. So this value is coming out to be 2. So today we are going to cover only up till this point only. So thank you for joining. Have a good day.